welcome everybody to the first technical evening of 2022 for the West of England branch. Absolutely delighted to have you here and introduce myself as the new chair of the branch for this coming year. I will just have a quick shout out and say we are always looking for new members to join the committee. So if you are interested in serving and helping out and shaping the direction of your local branch, then please do get in touch. You'd be more than welcome to join us. But without further ado, I'd like to introduce you to Stuart Greedy of OCL. Stuart is the founder and CEO of OCL and has an extensive experience working with aggregate companies in his previous life. But I will hand over to Stuart now to give a brief introduction of himself and talk to us about low carbon surfacing materials. So Stuart, please take over.
Thank you, Otto. Quick one, thanks first of all for having me along. Certainly, especially to Steve Cole for the invite and Louise for helping me do a little dry run to make sure everything works. I'm here today to talk about two things really. One is the classification of asphalt waste containing coal tar and why that's coming up the agenda for us all. And the other is certainly our family of low carbon surfacing materials. So basically in today's presentation, I'm just going to whiz you through why it's so important to classify asphalt waste containing coal tar. Why do we do it? But I'm not going to hang around too much on that. I'd then like to take you through two products which are used in the surfacing market, which is HBM and CRBM, Foambase being our proprietary mix, which is a base and binder replacement. Bit about their characteristics, bit about the specification journey we've been on, how we use them in the UK, and then some worked examples. So if I can kick on straight away, I just on the questions thing, I don't know if your group one's for chats or putting hands up or whatever, but if we could potentially leave it for a Q&A session at the end, I think that would be best. So for some reason, my machine isn't sharing, excuse me.
We can see your screen at the moment, Stuart.
You can see my front cover, but it's not letting me progress through the presentation. So I wonder what we need to do.
Your laptop something that you've got to actively click into it, so it knows that there you go. Actively clicking into it, then it works. That's moved on for us.
Right, fabulous. Thank you.
Awesome.
First technical glitch out of the way. So the classification of asphalt waste. I'm aware that I'm talking to the Institute of Quarrying, but really this whole piece is about how together we can be more sustainable and how we can hopefully increase the green credentials of certainly the highways sector, which I know is a big part of a big user of quarried products. Obviously, recently it's come up further up the agenda on the sustainability front. But so I'm just going to whiz through this because I'm guessing you guys already know a lot about it, or maybe don't need to know anything about it, one or the other. But basically, this is kind of where the cycle starts for us. We are all about circularity, all about recycling as a business. I founded OCL in 2006, and prior to that, I'd been working in the majors for 10 years. And it was from working on a really good job on the A21 down in Kent, where I kind of realized that I had an affinity towards the cold lay asphalt and the sustainability piece. And really, the classification of the waste is what drives it all. Asphalt waste containing coal tar must be classified. So anyway, in any highways maintenance works, if there's planings coming out of any job, that waste owner has a duty of care to classify that waste. So before it's collected or recovered, it needs to be classified, and hence the paperwork looked after correctly. And this is to prevent harm to people and the environment. So the duty of care, there's two pieces to it. The CDM rules, where a designer has to identify and minimize hazards, and the Environmental Protection Act, where any person dealing with a waste has to take reasonable steps to ensure no unauthorized deposits. Now that means in order to understand what an unauthorized deposit is, we have to classify the waste. So WM3 is the framework here in the UK. And it simply states, it's dead easy, that when you're disposing of an asphalt waste, and when we think about that, asphalt in the UK, milled out asphalt is often, if it's non-haz, it's sent back to the asphalt plants for reuse in RAP in the quarries or in the asphalt plants. And if it's hazardous, then it has to be handled in a different way. And all that WM3 says is you must prove the presence or lack of coal tar. Now, to demonstrate something's got coal tar, it either needs to be higher than 1,000 milligrams per kilogram of PAH or above 50 milligrams of benzoate pyrene. That is then classed as a hazardous waste. And I'll just go into that as quickly as I can now. So coal tar was a byproduct of the old town gas system that we had here in the UK. And basically it was a byproduct of that. It was black and sticky and a good binder. So at the time it was adopted for use like a bitumen in road construction. Now, like lots of things, we've become more sophisticated with how we look at wastes and how we classify those chemical pieces. And since those materials were used, basically it has been found that it has hazardous properties. So it's carcinogenic, mutagenic, and ecotoxic, and it damages life. So that means that any of the arisings from the maintenance of roads that are found to be tar bound, as we affectionately call it, or hazardous, need to be handled in a very specialist way. That means that they have to have the proper permits, the waste facilities do. And hopefully, like us, we have the permits because our process is cold, which we'll come on to in a minute. We are permitted by the Environment Agency to bind those materials, those wastes, back into base and binder course. And that's where that circular piece comes in. So we're recycling the planings at our depots, of which we have 6 across the country, and we are putting it back into a base and binder course. And that's probably the first touch point between our recycling business and the quarrying industry, because quite often those quarried stones, it's not a coincidence that asphalt plants are quite often in quarries and that asphalt uses a lot of quarried material. So what we're trying to do is protect that finite resource of quarried material and make sure that we use it over as long a period as possible. And we'll come into that with the circular economy a bit later. So if it's got coal tar in it, it's hazardous. Now there's a cracking document out there. This isn't for reading, it's just as a prompt for me to share with you this document. So ADEPT have done a fantastic document called Managing Reclaimed Asphalt. This is supported by the EA and endorsed by the MPA. And it's basically a flow diagram that helps you to make waste-based decisions and risk-based decisions so that you can correctly characterize your waste and hence correctly dispose of it. Now, the first thing about the tar bound, lots of people probably come across it in their working lives. It's got a distinct odor to it. The really quick ready reckoner is the pack marker, which basically turns yellow if it's found that there's tar bound present. But there's a word of warning here from me. There's a lot of false positives with pack marker, so it isn't necessarily to be relied on as totally infallible. However, it's a good quick way of making sure you're characterizing your waste. So if it turns yellow or it goes green under certain conditions, then that material is tar bound, and hence we need to start thinking about how we're going to dispose of it. Once you've identified that it contains coal tar, via the quick checks, you then need to get a proper laboratory test done, and that will help us to understand exactly at what level that contamination is. And the licensed facilities will require that test to be done so that they can handle it properly. Of course, as with everything, we like to apply the waste hierarchy. So if you can possibly engineer it out or possibly recover it, the worst case scenario needs to be disposal. And that's basically the waste hierarchy that we apply. Now, the Environment Agency have released 2 regulatory position statements on this topic, RPSs. So number 1, the first one is number 75, and that is all about the movement of and the reuse of AWCCT in approved methods. And 157 regulates the treatment. Now, they all centered around the fact that the contractor must hold the right permits. So basically, as I said earlier, those cold processes are permitted by the Environment Agency because, frankly, they've looked at the risk and they've deemed that it isn't going to be damaging to health, and it's a really good way of getting this material recovered and back into the asset rather than it going for disposal, which is obviously not very sustainable. So hopefully I've whizzed through that quick enough, but in summary, if waste classification, if highways are part of your life, then we can de-risk on the compliance piece so that you're making sure you're classifying the waste correctly, and the cost piece, because obviously recovering it and reusing it, we hope, is always cheaper than sending it to disposal tips, which are very scarce, and there's a lot of haulage involved, and it's not very good for the carbon footprint. And then we're maximizing innovation as well, which really is what OCL is all about. I mentioned about the depots across the country. All of those depots have bespoke permits. All of those depots are crushing and screening these wastes and turning them back into products such as CRBM and HBM. So those routes, if you want, are available. So now on to 2 of the materials. One that what we actually use the tar bound in these products, but this isn't just about that. This is about these 2 families of products that are available to the market as more sustainable surfacing materials. I'll just grab a slurp of coffee. Okay, so Foambase, cold recycled bound material, you'll hear it called, which is CRBM. And the specification for those products is the spec for Highways Works 948. So it's in the white book, it's in the code. And more recently last year, BS 9228 was published. And again, that is another standard that now covers the use of these materials. So Foambase is our proprietary trademark. There's others out there, but this is used as a base and binder course replacement. So when we're talking about surfacing materials, Foambase is an out and out to surfacing material. The product to the left is, to the right, sorry, is hydraulically bound material. Now this is a much bigger generic family of products. And you might hear, you know, CBGM, which is cement bound granular material. You might hear fly ash bound material, FABM. They're all that sort of generic family, and there's a lot more specifications for them. So you'll find them in 800 series, you'll find them in BSCN 14227, and again, more recently, BS 9228. BS 9228, I'll come on in a minute, but that is a new specification for the recycling of bituminous materials, and it's much more supportive, much easier to use. And because it's not a spec for Highways Works, it's not all around national highways. So this isn't for reading. These are available to you. If you want to pop me an email, I'll very gladly send you these, but this is just as a prompt to tell you a little bit about the product. So Foambase is an HRA 50, DBM 50 equivalent when we make it in the B4 classification. It's got all manner of benefits to it, which we'll come on to in a minute. But basically, the main one, and the one that we're getting lots of traction with at the moment, is that Foambase saves 50% CO2 compared to normal base and binder course, hot asphalt, that is. So lots of local authorities and stakeholders and tier 1 contractors are very excited about using these products at the moment and trying their best to get them into as many works as they can. Now, recycled materials, you know, they are innovative. You do have to have more control, more quality plans, more design mixes, and more compliance testing on your production to make sure that we're trying to create a more homogeneous stable and regular product. So an awful lot of work goes into that. HBM is more of a type 1 or a capping replacement. It can be used in some road classes as a road base, but it's not very common. And frankly, the main thing about HBM is that it creates like a performance foundation. So we're replacing primary capping and type 1s with these products. When we think about the waste that we're recycling, it's not a coincidence that it's been mainly planings and mainly highways wastes that we do work on, because there's that closed loop thing. So depots can receive breakout or asphalt from the maintenance schemes and crush it and screen it and mix it and send it back, which is obviously keeping those lorries loaded in 2 directions and really making the best of the circular economy drivers that we really work to. And you can see here that we're recycling the asphalt waste containing coal tar, but we're also recycling non-haz asphalt waste. Now, this part of our business over the last 3 or 4 years, we've noticed has diminished somewhat, because the non-haz asphalt, some people call it clean asphalt, some people call it inert asphalt, although it's not. The non-haz asphalt can be reused in hot asphalt. So a lot of those big assets, those big asphalt plants, are maximizing the amount of RAP that they can get back in. So commonly, 20 years ago, I used to get an awful lot of RAP, an awful lot of non-haz planings. Now we get very little because they're being used so well by the rest of the industry. And then the other part of our business is that we're recycling concrete and mixed C&D waste at our yards. So that's concrete and breakout and what have you. And also soil and stones, both haz and non-haz. And we're making those into HBM. And what we really try and do is maximize the value. So we try and take a waste, which sometimes the worst case scenario is it might get flogged to a farmer for an access track, or it might have a very low value piece that is not unlocking the value, whereas we try and move it up into the maximum value product. That's part of our ethos. So Foambase, the benefits are that reduced CO2, reduced cost. Everybody in our industry is feeling the impact of the haulage issues, the energy issues. I say issues, that's a negative word, challenges, the increase in costs, and basically asphalt prices have gone up as much as 20% in the last kind of 2 years. And that's a big thing for the industry to take. So Foambase is good because it goes further. It goes 15% further. So ton for ton, you get more work out of it. And also there's a reduced cost piece, which obviously helps us to market the product. It's made up of it's 94% recycled, the best example, 100% recyclable. And more with those haulage issues and those programming issues and shortages of stone and all the things that are impacting, self-delivery is a saying that we hear an awful lot about every day at the moment. So the fact we can mobilize to site, we can do on-site batching, and we can protect projects from some of the vagaries of material supply at the moment is really interesting. Now, HBM isn't as sexy on the green front. So Foambase is saving 50% CO2, but HBM relies on a hydraulic binder. And hence, although we do use SEM-free, we use cementitious alternatives, it's not as good with the green credentials. But what it does do is allow the reuse of a lot of bogey wastes, if you want, waste that might only go out as a cheap fill or a cheap type 1. We can use those and get them up that value chain as I was describing. And that means that you can go thinner on the asphalt. So because we're making a performance product, replacing a type 1 with something a bit better, some designers can then thin up the asphalt design, which is good for the environment and another way of protecting those finite reserves in the quarries. The other thing it does, and one of the big drivers, one of the big things we enjoy in our business is tip and take. So we really strive for the wagons that are dropping off their waste to collect their product and go back to the site, so that we're trying to ensure we're loaded in two directions. So the climate piece, I'm afraid I wouldn't be doing my job if I didn't just quickly go over this. I know we've had it all at the very forefront of our minds over the last few months, but we call it an imperative. Now, I've been calling it an environmental imperative for 10 years now. Obviously, with the advent of COP last year and the fact that we now all understand scientifically that we've got to keep 1.5 alive, there's a huge drive on, and you know, to reduce these CO2 emissions, and we've all got to do our bit, be it domestically or commercially at work. So these documents, these documents have really come around recently, and you know, some of these dates are very, very close to us. These have supported sustainability and green products really getting some traction. I think that the UK was a bit behind the curve, if I can be truthful, but I do see there's a lot of acceleration now, and these documents and the testimonies we're getting now, this is two examples, and really I show you this so that you can get a feel for the acceleration. This is two new depots opened last year, one for Hampshire, one for Oxfordshire, but you can really see, whereas we were rowing our own boat and finding our own way for 10 years or so, now we're getting that traction. This is all cabinet driven stuff. So the place I think this has got touch points in the quarrying industry as well is that we are told that within quite a short space of time, local authorities and the big stakeholders will be viewed, their budgets will be given to them on a kind of environmental scoring. So they have to be seen to be doing the right thing now. They have to be making carbon-based decisions. And this is just two depots late last year, which I helped set up, and we enjoy working with our stakeholders there. And it's just to try and show you how quickly these things are kicking on. So you've heard me mention circular economy quite a bit. In the quarrying and the highways industry, for a long, long time in the UK, we lived on more of a linear economy, which was kind of make, use, dispose. But the circular economy is so important for us now, reducing waste and basically delivering a more environmental and competitive economy has really come to the fore. So with these cold laid products, there's nothing to stop you using them again and again and again, because there's nothing in the recycling process that precludes that. So it's very important that we extract the maximum value from all of these resources. Now, this is where I talk about the linear quarry concept. So National Highways make some fairly brave statements about this. They say they're the biggest quarrying company in the country because of all that stone they've got locked up in their assets. When we talk about linear quarry concept, we're talking about the fact that with that circularity focus, the road of tomorrow can be made of the road of yesterday. So on the left here, we have a traditional quarried stone kind of road design, which the capping, the sub base, the base course, binder course, and surface course, all of traditional materials. And on the right, we have the road design that we try to champion. So the capping and the sub base replaced by an HBM, and then the base and binder by Foambase. And the only piece that remains, the hot traditional version, if you like, is the surface course. And that's because basically that is the human piece, that's the public realm. So that is what people walk on and drive on. And we all know in reality that recycling can have the odd fleck of this or the odd piece of that in it. And it doesn't matter how vigilant we are, that's always going to happen. And so there's a lot of work going on about low energy surface courses, which we'll come on to shortly. But that recycled content for performance and for the reasons I just mentioned is more like sort of 30, maybe maxing out at 50% recycled through. And that's with a lot of vigilance and a lot of discipline at the waste end of that. So I don't know if you can see that, because some of the screens I've got have actually blocked that out. I don't know if the same for you guys, but this is a study done by Lafarge Tarmac, as it was at the time, obviously then went on to be Tarmac, and the Carbon Trust. And this was, I think, about 8 or 9 years ago, when they started to talk about the carbon footprint and the savings that were available for certainly warm and cold products. So there has been an awful lot of work done by the majors, a lot of good work about warm asphalt. You've probably all heard it being talked about. And really importantly, national highways just last year now have allowed its use without a departure. So a lot of development going into warm for the obvious reasons. You've got that 9, 10, 11% carbon saving. Similarly with the cold, back in the day when this was written, it was talking about 40% savings. We're now up at 50% savings, because like anything, we've refined that. We've become a bit more sophisticated, and also we report it more accurately. So when we talk about CO2, we've got that fantastic ability to really make a difference on some of the big volumes. Then we've got whole life cost. So, and this really is edgy stuff. I can't share with you enough that these two pieces have only really come about in the last 2 or 3 years. We've had the carbon, we've got the cost, and we've got how we're looking to spend the local authorities' budgets and make the money go further. And this whole life cost study was done by ADEPT, so obviously a very reputable organisation, and Skanska and Oxford County Council. And they proved that using our B4 binder course with a control surface course, which was a 10 mil, basically on roads from 2.5 to 10 MSA, that's million standard axles. Using these products, you can also save 20 to 30% whole life costs. So we've got that double benefit. We've got 50% CO2. We've got 20 to 30% cost. So really, there's an awful lot of work going into this at the moment. And just today, I had a phone call from a friend in one of the big test houses who's advising national highways. And they're looking to build on what they've achieved last year with warm, and they're looking to make changes to the DMRB, the design book, if you want, to get these cold products into more roads in the UK. Again, a very busy small slide, but this is available for you if you want it. Just drop me a line and I'll send it to you. But this is where we're working and validating and verifying the cost saving, the carbon saving, sorry, of 50%. Okay, so a little piece about the specifications. I don't know who in this group is specification driven, but we have been on quite a long journey with these products. But it's really important that we apply their use pragmatically and that we stick to the specifications so that we don't pick up any risk. 2004 time, we were using TRL 611, report 615. And then really we've been on a whole journey in between now and then to the most recent incarnation of the design book, which is CD 225, 6 and 7. And as I mentioned earlier, we've got a really good spec now in the British standard, which is 9228, and that only came out as recently as September 21. So what I'm trying to share with you is the fact that there has been backup, there has been a long journey on these specifications, and just recently there's been a new specification. This is just pictures to basically share. This is kind of a one-size-fits-all presentation, so I can be giving this to designers or to local authorities or etc. So this is just literally a pictorial version. And this is where I would share just how useful I think that BS 9228 specification is. Clause 948, although great and a big step on from 611 in my view, is just about National Highways, Highways England as they used to be. It's about their kind of work, whereas 9228 is a kind of a lot more of a useful document, a dummy's guide, if you will. It kind of looks about how you assess the site. It gives you how to do the mix design, how to sample, how to test, how to look at the tolerances, aftercare, and all of the above. So it's a much more usable document for someone like, say, a developer or someone who was putting in an unadopted road or someone like that. So this is, you know, trying to increase the use of these products and again, protect that finite resource back in the quarries. Busy slide, don't try and read it. DMRB, this is a document that AECOM wrote for us, and this basically proves that our B4 class product is a like-for-like replacement for DBM 50. The nomograph on the right lets designers actually refer to what was then HD 26 and lets them make design assumptions using those products. So it was a big step forward for us to try and get some of these products into those bigger jobs. But actually, in reality, 85 odd percent, 87% of our roads in this country are all minor roads. So when you're looking at that chart at the bottom there, major roads, trunks, principals, etc., that's kind of National Highways field. Minor roads is something that you might call like a local authority road, the roads that the majority of us drive on for the majority of the day. And these DMRB designs are over-engineered for those. So they're more like an evolved network. They're made up of various layers of bits and bobs that the local authority have applied over time. And so we're targeting the designs in those roads because that's basically where we can get most of the opportunities to get those wastes back into the network. This is some examples. Again, I know it's very small and very fiddly to read, but this is where I talk about the non-DMRB examples and where we're getting traction with local authorities. Oxfordshire, Northumberland, West Berkshire, Hampshire. We do work in Lincolnshire. We've done work on the Sheffield PFI in Kent and all up and down the country, which is kind of testament. We've had no failures. We always provide that service where we're providing the design to de-risk the customer. So these are examples, some really good examples of where those products are getting used day in, day out at the moment. Moving on to HBM. Spec for Highways Works 800 or BSEN 14227, but again, BS 9228 there on the left was written about the CRBMs and the HBMs. So that useful document can be used again for specifying HBMs. And then really importantly for us, the SROH 4th edition, May 2020, also now states that HBMs are a standard material. So you don't have to do any aged analysis or any of what we used to have to do for Appendix A9s where you had to apply to the committee and get them to study stuff for 2 years. That's all been taken away to increase the use of these products because there is a track record. HBM's been used in the UK since the 50s and 60s. So they don't want to block the use by being overly bureaucratic. Now, just a quick piece on quality. Everything I've said is from a standpoint of a company who have the benefit of the quality systems and understands the spec, and we've been at this for nearly 20 years. Now, there's a lot of ability. It's like anything, that recycling bit where someone buys a crusher or a planer or a mixer and they think that they can just crack on. But what I do an awful lot of talking about is the pragmatic use of these materials, because you're only as good as your last job, and you do have to handle them in a discreetly different way to normal products. That can only be shared by companies who have 9001. And in all those specifications, it says that the manufacturer of those products must be stated in the scope. And that's a precursor to the whole quality piece. So yes, you can go and buy all the kit and you can have a go, but basically to get that quality outcome, you have to have the certificate of registration for the 9001 specifically for these products. Okay, so now I'm just going to whiz through a couple of the methods that we use here in the UK. So you'll find three methods, one being retread, which is the shallow sort of scarification and regrading and compaction of the roads. Then you've got deep in situ. We've probably all seen the big rotavator things on the big flotation wheels that are going down 75 to 300 mil. And you've got ex situ, which I've got a bit of a focus on because it's exactly what we do as a business. So retread is really good bang for your buck. Deep in situ is a good treatment. You're getting a lot of depth of treatment. And then ex situ for us, we're removing that road normally via milling. And then the arisings are brought to the depot where we crush and screen them. And we're more like a virtual quarry. So you've got a surge pile, we crush it and screen it, we approve it to a grading before it then gets adopted into the manufacturing process. Just some pictures of what that looks like. This is retread being undertaken here by Colas. You can see it's quite agricultural. It is good value, but quite often not the longest lasting process in the world. You've got deep in situ, which is a lot more invasive, a lot more energetic, and then you've got our processes, which is like the factory, and obviously we're getting the outcomes that are more akin to a hot asphalt plant because we put it on a lorry, it gets laid through a paver. The pros for retread are that yes, you get a good fix, a quick fix and good value for money. The cons are it only treats the upper pavement and quite often it leads to revisits. Deep in situ, great outputs, good value for money. The cons are very invasive and there is a propensity to over cement. Now, anybody who understands pavement design knows that we like a bit of movement down low and we don't really want rigid foundations and rigid base courses in this country because it can lead to reflective cracking in the upper layers. So that is one of the risks when we talk about deep in situ. When we talk about ex situ, the pros are factory process control. We are basically an asphalt plant with instead of the quarry, we've got our feedstock. The cons are there is again the ability to over cement, so you can go too rigid if you haven't got the right quality control in place. And also the scarcity of depots. It's all very well us having this Wizzo product that's being adopted more and more, but basically for it to work, there needs to be more depots because there's only probably 10, I would say, in the country, of which 5 or 6 are ours. And so it's very hard to promote the benefits of a product when they're few and far between the depots. So I'm just going to take you through a few examples. So bearing in mind that this is about recycling and this is about low CO2 surfacing. So this was a great scheme that we did in Ebbsfleet Garden Village in Kent. This is an ex-tarmac Blue Circle actually cement works, and they had just demolished all the infrastructure and it was sold actually as a giant housing estate. So we were lucky enough to be invited to work on site. We recycled all those old assets. So we were crushing concrete and digging up the old roads and what have you. And we made an HBM and Foambase design where we put in all the spine roads and all the infrastructure roads for this whopping great housing estate. Luton Airport was a big piece, a big feather in our cap, because it was the first time that HBM and Foambase or foamed bitumen, foamed asphalt was used in a taxiway. We also did the long-term car park. So now we're playing in the realms of the super duper consultants, and it was massively technical. There was an awful lot of attendances on site, and we had to do a lot on the design. So we were very proud to get that one over the line. And then recently, if I wanted to give you an example of a big scheme, we did a massive lorry park in Ashford in Kent. And this was a great case study for us because we got the high output work going. So we were doing 1,200 ton a day, which any of you guys that work in the asphalt side of the quarrying piece know is quite a challenge at the moment. We saved 25% cost over hot asphalt. We saved 15% reduction in material, which was the density that I described earlier on. But that one scheme saved 629 tons of CO2, and we got an award for that. So that was just one scheme in Kent that was saving that much CO2 being emitted, which, you know, we're really proud of. And then some local authority stuff. I'm just going to whiz through these. In Somerset, from our Avonmouth depot, we work with Wainwright. And here's an example of a contracting company who's got their own asphalt plants, but they're very progressive and they're very proud to be working with us because it helps them with the local authorities. A great example of circular method. They bring the waste from the local authority maintenance work to our depot. They take the Foambase back and it's laid back in that same road. Similarly with Hampshire, we've got an annual contract there, so there's big CO2 savings, big cost savings. And Hampshire's quite a tricky county to get stone to, as you know. It's coming down from the Mendips or it's coming in by sea. And so there's quite a lot of CO2 and quite a lot of costs associated with getting penetration for aggregates into the Hampshire area. And this is not a coincidence as to why recycling is going really, really well down there. Stubbington Bypass for tarmac, just concluded the main surfacing package. We're still there on footways at the moment, but that would have been 18,000 tons of our products by the time it's finished. We're up in Northumberland, working again with DSD for the local authority, making those carbon savings. Same with Oxfordshire. Sorry if these are a bit repetitive, but I quite often have different people who want to see different ones. So in summary, we can affect change together. So we're talking about the sustainability piece and the circularity. So we're trying to make sure that we protect those finite resources. We can collaborate on risk through long time served relationships and work that's been in the roads for in excess of 20 years now. And developing opportunities and collaborating is really a big part of what we do. We've got 3 local authority tripartite arrangements so that we're getting that recycling bit and that low CO2 bit out into the market. So we can make carbon-based and waste-based decisions when it comes to designing. We must move away from this mental copy and paste scenario where the last spec works, so we're just going to go with that again. That's not innovative. So we can drive innovation together by changing the way that we think about that. There's a quick video just before I finish, which was done by our chums up in Lincolnshire. Just gives you a nice little vision of what we do and how it looks actually out in the field. And that's me.
That's great. Thank you so much for that presentation, Stuart. I found that really interesting. And I have to say, I was actually quite surprised at how much work you are doing with companies, including Tarmac, who I work for. As I was completely unaware of that, so really interesting to see.
Yeah.
I'll start with a question of my own in a minute, but if you do have any questions for Stuart, please either raise your hand through the reactions function or add them into the messaging chat. We'll pick up on those. But just to start for myself, Stuart, what do you think are the biggest barriers to adoption of this technology? Is it a perception, the councils in terms of their specs?
5 years ago, I would be talking about barriers, but things have changed so much recently that I'm starting to think those barriers aren't there anymore. I'd probably swing that around and say, where are the ones, where's it working best? And it is working best where it's sort of cabinet down rather than contractor up. Without jumping on my soapbox and sort of putting too many noses out of joint, when I started this company, I was lucky enough to go to Australia, South Africa, Canada, who were big champions of this technology. What we're doing isn't new. It's been around. Mobil had the license for it in the 40s and 50s. But the difference there was that the surfacing contractor wasn't coupled to the aggregates company. And so they could make decisions about recycling in a lot more neutral fashion. So I think now that we've got that, it's polarized in this country. Most of the big works are done by the quarrying companies who have their own contracting arms. And so no matter what we say, there is an incentive for them to get their product in the ground. Now that product's more scarce. Now we know we have to do more environmentally. It's a level playing field. So I think those barriers are coming down.
That's great, thank you. We've got one question in the chat from Joanne Baker. We've got carbon savings in binder courses. Are your figures based on using 100% primary aggregates, or do they include a percentage of RAP? So as you note, the non-hazardous RAP is being incorporated into the new hot binder courses, and some asphalt plants are incorporating quite large percentages of RAP into binder courses. So what's the CO2 comparison on those mixes that include RAP?
So those, great question. Those have used an average. We tried to pick an average for the market. People are getting as much as 20% into surface course now and 30% into binder course. So we used those figures because we believe that's where the industry is going to be in the next sort of 12 months. When hopefully the majors, the hot asphalt plants improve on that, we'll obviously adjust it.
That's great. Hopefully that answers your question, Joanne. Give it another 30 seconds to see if any more questions come in through the chat. But in the meanwhile, I've got another one. Kind of how pervasive is this tar-bound material still in the UK? And I don't know if you've got any estimates on how much of it's still left in the ground. Is it becoming more scarce as kind of, you know, the roads get older and have been resurfaced increasingly?
What we find is that here in the UK, we've had behaviourally, we've just been making surface rehabilitations. This stuff more often is lower down, and because those roads now are 30, 40, 50 years old, those lower layers are failing. And therefore, we're seeing an awful lot more of the tar-bound that needs to come out. There is a document out there, forgive me, I can't remember by who, but they estimate it at 200 million tonnes. And when people say, oh, I haven't got it in my county, they're just not testing for it. It's everywhere. I can personally vouch for that.
It's really interesting to hear. I was kind of of the wrong impression that this would be a decreasing problem, as you know, those roads from the 80s get further and further into the past. But it sounds like it's the opposite.
Yeah.
Thanks. Are there any more questions? And you don't have to put them into the chat. You can ask them live. Just put your hand up. Can't see any at the moment. No, okay. Well, in that case, that draws us to a close, and I'd just like to thank on behalf of the whole of the branch, say our thanks to Stuart for giving up his time this afternoon for a really informative presentation. So if we had you in the room, Stuart would be applauding loudly. So thank you very much.
It's been a pleasure. Thank you very much for having me along. And my email address is there. If anyone's got any questions or wants any data sheets, just drop me a line and I'll share them.
Excellent. Thank you very much.